All right. I'm here today to talk to you guys about JavaScript. Not because I particularly like JavaScript or anything like that. I actually don't really like JavaScript despite spending a lot of my time writing JavaScript. I like to make the joke that when I'm programming JavaScript, I speak JavaScript with like a Haskell accent because I really, really like functional programming, which is one of the reasons that I like Urbit. So I'm more so talking to you guys about how over the past handful of weeks, months, working on the project Golem at Archetype, I've been writing a bunch of JavaScript so that you don't have to write as much around your ship, right? Because ultimately, this is like what we'd all rather be working on. We want to build things that last, that have permanence, and make a massive impact when we talk about things like building the 1,000-year computer. But when it comes to building a 1,000-year computer, obviously I don't want to wait that long to build my applications. And so I always have this kind of question of like, well, what does year 2 look like if you're moving towards this 1,000-year computer? And when I think about this, I usually like to go back to like not a quote, but like a soundbite from like a discussion that I was having with Galen back during one of the like, UAC events in the fall, where we were talking about how an app should be built. Specifically, he asked me if I know how an Urbit app should be built. And pondering that long afterwards, I realized this is actually like 2 questions in here, what I like to call the 2 questions of the application. There's a question of, how do I want to build tomorrow? What's the ideal way to build? How should an app be built? And there's a slightly different question of, how do I have to build an app today? Like if I want to build something and ship it tomorrow and have users, how should that be done if that's the constraint that I'm working with? And actually, these are 2 very different, you come up with very different answers to these in Urbit space in particular. And so another mental model that I like to call back to here is, if you've ever heard, there's like this quote about the society is good when old men plant trees that they will not live to see. And that's what a lot of Urbiters are doing, which is really inspiring to me. But I think we have some unique constraints on our system because unlike a tree where you wait for it to grow and then you can sit in its shade, you don't sit in like the shade when it's under the ground or like a sapling, right? But an operating system is not like that. Today does affect tomorrow, and you not only need to be building applications, but there's also an ecosystem, especially in a platform like Urbit that's a network and that needs multiple nodes in order to make sense. Like you wouldn't do anything the way Urbit does things if you wanted to build a personal server for your own applications that don't communicate with any peers, right? And so you need a 1,000-year ecosystem, otherwise what are you building this like computer for? And to that end, you need to be growing this thing like soon, which means you need to be shipping apps today. Because you have this problem, it's not just today into tomorrow, but there's like day 1, then day 2, 3, 4, 5, 6, and so on. And then each of these, all the way until like day 1,000,000, is going to have like some, like the best practice, which will change over time. And so coming back to this like imagery of what we're all going after, lasting network, a wonder of the world in a sense. It didn't always look like this. When people were actually building it, it looked something more like this, right? Where there's actually not just the pyramid itself, but there's other shit around it that's temporary, that is useful for getting shit done today. And this is how I think about a lot of the stuff that I've been working on. When you conflate those 2 questions of the application, like how we should be building in an ideal state and how we should be building to ship something tomorrow, when you conflate those, you sort of end up like nitpicking or like critiquing all of the things that like need to exist to make applications real today. But that's actually sort of like missing the point. These 2 things are actually in orthogonal problem spaces. And there is some unique advantages, right, to this decoupling that happens. Because ultimately, like decoupling these things means that you can reason about each of them respectively in their own problem space without conflating solutions that are really good for one of them, but actually is an antithesis of what you'd want to do in the other. And then in particular, it's probably monodirectional. Like you, in the temporary space, you can do sort of experimental things that you probably don't want to pollute the sort of pristine pyramid that you're building, right? The mud can exist around it, the scaffolding can exist around it, and so on. And you're basically building migration paths because on each of these like hops, again, there's going to be best practices that change over time in order to make software happen today for whatever current company's goals are to like build and get users and ultimately grow the 1,000-year ecosystem for the 1,000-year computer. You'll be building the whole time applications, the ecosystem, everything. That's the ideal state. So this all begs the question, okay, great, sure. If you understand this point, it's like, well, what actually are you building though? Like what are you specifically doing? And so there's a few things that we've done thus far that start to address some of this like outer scaffolding, right? So firstly, there's Clack, which is a JS wrapper around Lick so that you can actually make changes in your ship from the Earthside environment when you need to in order to do things that you want to do for your development experience. There's Golem, which is like ship automation. This is a CLI. It actually uses Click in order to do those things. And then we also have Eigen and Void, which is our package registry built on top of Near. It's on a blockchain, so it's permanent, and Void is the viewer. This talk is about scaffolding applications and building, so I'll primarily be talking about the first two, but you'll also hear about the third bullet point there more on Friday during Seth's talk, but we also may end up using it in the demo depending on how much we're able to get done during the build portion. And so just a brief overview of each of these things before I dive into them. So Clack, like I said, is a JavaScript library. It basically does some things to interface with conc and like the convein, ultimately in order to do things in Urbit land. And what that looks like on like a practical basis is it has JavaScript that exports libraries for Newton coding and like jamming nouns so that you can access those affordances from JavaScript. It does some like noun conversions. This is similar to what Palfun was talking about earlier. You run into the same problem if you're doing the like mark conversions in your React app, quote unquote. But it's also a problem, you know, when Clack's talking to Con. So we also like export some types for interfacing with Con's types from a JavaScript environment. So Con, Feared, threads, things like that. And what that gets you is you're able to do stuff like mount, commit, revive, or even send custom threads to your Urbit, meaning writing some Hoon code that's in the JavaScript string that you can say, hey Urbit, hey FakeZod, go do this, which gets you like a lot of affordances for building dev tooling. And so what it actually looks like is, here's a snippet of like code from actually like the testing suite does stuff like this. So you instantiate like a Clack object using the path to the ship you're automating, which in this case is a FakeZod. And then there's some like nice syntactic sugar for doing things like creating a desk, where you pass a desk name and mounting it and so on. And you can do normal JavaScript control flow to do all this. There's also what I would call like manual mode that doesn't use those like nice just import a library and do things. This actually uses some of the like types that I talked about for like feared, thread, and so on. Here, what we're doing is we have an inline JavaScript string with some Hoon code. We instantiate a thread object with that, await for the result, and then we're able to use that with this sort of like syntactic sugar for just like sending that thread without necessarily creating the whole the wrapper that had those other convenience functions on the last slide. And then ultimately we get like the response JSON, and this parse thread response is like slightly coupled to Con in that it knows how to unpack Con's like outer wrappers around the noun that's ultimately returned from the thread. So instead of getting like a noun shaped like what Con sends you, you can just get this like success message that this thread sends back, for example. And so how we use this is to build Golem. And Golem is a system that takes in a handful of messy things that are annoying to deal with. So it actually has some code for grabbing your latest Urbit binaries. It has some code for grabbing Garden and base dev. I'm sure everyone who's developed a Gol app here probably has like been cloning those from like GitHub and like curling and doing like all these steps to create an application. And it also knows how to get packages from our registry eigen. It uses Clock under the hood using code like what I just showed you in order to create a development environment that has these sorts of things. So folders of apps, like different apps that may depend on each other, fake ships, so different environments with multiple ships that can like test those apps and how they interact with each other. And then also like a separation of dependencies from the apps themselves so that you don't have all of the files in Garden and base dev in your like app lib, mar, and ser folder when you're doing things. And so what this gets you basically is like templates and scaffolding. You can use this like CLI to generate projects and get started. We have a few different ones. Obviously, if you want the least amount of opinions possible, you get an empty agent. We also have like an example CRUD app that uses React as a front end. If you've done App School 2, this is like largely based off of a simplification of that code. So I chose to do that because for people who are coming from a development background rather than like fresh and not necessarily going through like Jack's courses, the easiest way to like do one tutorial and then get started with this like scaffolding tooling would be to be using patterns you're familiar with. We also have templating for like creating a sail project that uses sail to serve a website. And also you can do other things like add a template that has a Gall backend, Phaser front end, or Urbit backend. And there's a framework called A-Frame that lets you do VR in the browser. So if you want to store some state about your VR application in your Urbit, but you want to, through the browser, like serve a 3D experience, you can do that as well. The other thing that's of interest, it's not a separate template necessarily, but with the empty agent, what you also get with that is there's this like decentralized front ends narrative in Urbit where you're just using the glob basically to deploy some app that normally would have to be hosted somewhere else. You can literally clone the, or like generate the empty agent, put in your decentralized front end, and deploy that to your Urbit without having to do all the manual steps yourself. So this makes those like impressive things that we got excited about kind of like trivial for any reasonably competent developer to do. And more. So like the thing here is that these can all be extended, and my intention is like I want to make development the way that it is done at any given point in Urbit as easy as possible. And I think this is enabled uniquely by building all this stuff on the Earth side. If we built a bunch of stuff that was tightly coupled to like Gall, for example, when we have like other teams like trying to create new and better ways of doing things, it would maximally like disrupt what we're doing. Whereas this way, it's like fairly trivial to like anything that can receive messages from Khan can sort of like get this like bootstrapping power that we're creating with no sort of like conflict of interest or like opinionatedness on our side, which I find really nice. So yeah, one of my favorite things about this and the initial rage-driven development that resulted in us doing this is the onboarding flow, which I'm really happy with. It looks something like this, which is once you install Golem, you basically in 3 commands can get your environment up. You run Golem new, like my cool app, whatever the name is, and it'll actually create a project for you. You can CD into it, and then it'll have all of the like files and like dependencies and stuff, but it won't have the environment yet because you may want to like add more ships if you want to bootstrap those. But you go in and run the init command, and then it actually will create your ships for you, make sure you have the latest Urbit binaries and so on. And then once you have both the project and your environment, next step, make them kiss. You run Golem build. It'll actually take your dependencies. In this case, by default, that's Garden and base dev or anything else you installed if you grab packages from eigen. It'll collate them, put them onto one or more of the ships in your ships folder, and you're good to go testing in the browser. The thing that I find really compelling about this is that if you want to attract developers that are building applications right now, which is to say application developers rather than systems developers that want to build on Urbit, they want to evaluate Urbit as a technology for their use case, and they may not even be like on groups yet or like doing things like that. And I think there is a pretty high barrier to entry to like getting started with your fake ship, and most people do that after they've already gone on the network. But if you're merely evaluating it as a technology, you kind of like immediately rule it out if you can't do something like run these 3 commands, go to your browser and see what you're getting when you create a project. And so now we can look into a little bit of what this looks like. by popping out of slides and over to some code. So I have a little folder sandbox that I set up to demo some of this. So we have golem installed, and we can do like golem new demo 1 and show you what the project structure sort of looks like. We're going to build a CRUD app because that template is sort of the most interesting to demonstrate like kind of what we can do with this. And as you can see, what it's doing right now is it's actually like managing sort of like the GitHub dependencies for you. So the like garden and like base dev stuff that you normally would like manually be doing to set up your test environment. It'll grab those, which, you know, dependent on like sort of network speeds. And once it grabs those and like collates everything, we can actually go into the project and see what the structure looks like. And if you're poking around, there's also like a skip depths flag that will let you just create the project if you want to see the templates without necessarily like waiting a minute or two for the base dependencies to install. But it was pretty quick, much quicker than setting up the environment. And we can actually CD into demo 1. And I'm going to open that up in an IDE, which in this case is Cursor. And oh, great, it left the large text. Perfect. So you can see, can people see this actually? Yeah, I'll make it maybe slightly larger for this section. So we have an apps folder, we have a ships folder, and we have this ships.json, basic git ignore. And ships.json basically just configures, it's a list of ships that has a list of the desks that need to be on the ships for your testing environment to work. Right now, by default, we just have one ship to test on Zod, which will have one desk, the desk that we just created. And as you can see, we have like a project. The project has the desk code, and next to it is also the UI code, which is a React app. This is a pattern you might see some people using, although everyone is kind of rolling their own, but roughly converging on this. So the thing that's unique to us, though, is this desk depths folder, which actually has separate projects for anything you imported. And by default, you end up with landscape, which is garden, and Urbit, which is base dev. And they have all of their files, which means that importantly, all of the files that you normally have to get from here are nowhere to be found in your actual desk. It's just your app. It's just your lib, your types, and so on. You can actually look at like a sensible like working tree, right? So that is the basic project. And once we're in it, we will also run golem init to set up the environments. That's basically as fast as creating a new ship is, which right now is about like 5 to 10 minutes, which doesn't make for a good demo. So I took the liberty of running that step ahead of time in a JSON directory. But this project, demo 2, is essentially the same project we just generated, but we've run golem in it, and we actually have the ship set up. So we can start doing some hacking. So if we open that one up, you see something similar, but the difference here is that there's actually stuff in this. Oh, this is the wrong one, isn't it? Yeah. Yeah, so, well, the one that we just opened, the ships folder, was empty except the keep file that we generate. And let me do this differently. All right. So, yeah, maybe there. Nope. Why don't we close you, actually? OK, so yeah, so we have the our ships folder, which actually has Zod in it now, which actually has demo 2 in it. And if we want to make sure that we have everything in it that it should, we can actually go into our terminal and golem build. And we'll see what it does, which is it goes through, starts the ship if it hasn't been started. This is it running Vite to like build the yeah, I think that should be fine. Oh, yeah, it just looks, it's printing weird because of how large it is. Yeah, so it built both the Urbit desk and the React project, and it moved the Urbit desk into the Zod, as well as using Clack to automate committing it. So we should be able to go to it and log in. but we also need our code to log in, so we're also going to use another command, golem shell, to actually connect to the running, that running Urbit ship that we just created. And we can both get the link to the web interface, which I'm actually going to open in Chrome because I think that will make the demo better. And it'll also let us run the code command to actually log in. Okay, yeah. So no newsfeed eradicator. Okay, so here we are. We have Zada running, and we want to get into it. And as you can see, actually, yeah, that was cached. But we do still need to upload our React app to Glob to actually have the app here. It also looked like there was no loading sign, so I'm just going to run build one more time because sometimes there's occasional failures. But those are usually irregular. They can be fixed by rerunning it. And yeah, okay, that looks right. And let's golem shell in. What's going on here? Oh, you know what? This might be the other demo ship. So I think the ship from the other demo might be running. So we can actually golem kill, which will search for any like running ships that it's created and kill them. Although it said no ships are running. Okay.
It crashed right as you ran back.
Right, okay. And yeah. And then shell.
Is it the port, maybe?
Yeah, I think it's the port, yeah. But it shouldn't serve anything if it's down, actually. Well, we'll see. We can poke around. It's the fun of live demos. Now we want that. So it has it has demo 2, and it says demo 2 is running. So I don't know why it's not rendering. Oh, I understand. Okay, that would be why. Great. Well, we can update that. Yeah, so in your desk. Good catch. And now actually, this is something interesting. So actually, I'm going to undo that. So this creates something interesting that we can do. So we can actually open up multiple terminals. And build is how you like build the application. But ultimately, that's a little bit clunky a lot of the time. In practical cases, you might want a watcher. And we do have golem watch, which will look for file changes in both the desk and the UI and rebuild everything when something changes. So we can actually change it to 4.11. And we can watch the watcher pick that up. And then we should see, yeah, the ship update. Yeah, if we were at the bottom of the terminal, you'd see that update run. It looks like this, essentially, right? You can see like what Clack sees in that window and what your Urbit being automated sees in that window. And it's even more fun when you have like multiple ships up and you can see it do one ship, and then build the React. Cool, okay, so we have that. We fixed the Zeus. Damn, all right. Well, let's see if Docket knows that it's there, and maybe that will solve everything. Great, okay. So yeah, we'd have to do this anyways. I don't know why the spinner wasn't there, but obviously it's on the ship. So what we want to do is we want to find the project we just generated, which is in like demo 2, apps, demo 2, UI, dist. And we upload that. which is a pain the first time, but you can kind of like click through this subsequent times. And we're looking into automating it as well. And then once that's up, let's go back to our main ship. And we see nothing. That's totally wild.
Click log, by the way. Click the button. Yeah, enter.
Let's do it again.
Just try and navigate to the URL that it should be at.
Yeah. /apps/demo1. No, demo2. Yes, it's demo2. That's correct. Great. OK, demo2. You know, landscape bugs. What are you going to do? It was behind the curtain the whole time. OK, so yeah, so basically what this is, if we look at our agent first, what you can see, right, is you have a desk. And this basically implements like a basic CRUD on like one data type that has one property. So we have, in our SIR, we have an item. And if we minimize our console, you see an item has like a name. There's a list of items, which is a map of like ID to item. And then we have some actions for updating it and updates for publishing out to anyone who wants to subscribe. We have sort of the like associated like MAR files, which like run the encoding and decoding functions. If you've gone through App School 2, all of this should look super similar to parts of that. We don't have like the log thing that they do in there. And your library, of course, does like the infamous like JSON encoding and decoding, right? But you know, this data type isn't super interesting. And what we're really here to do is see like how quickly does this get you up and running, and like what can you do with it, and like how can you enable just faster development and development that's like more familiar to people who are new to the ecosystem and like more on the application side than the system side. So if we've gone through App School 2, we know to edit our data, we basically want to change this item type, right, and want to add something interesting. If we want to turn this template, which actually I guess I should demonstrate that this trivial React app basically just sends a poke and then scries for the data in that item type, so we can send it like foo, and it'll create that twice apparently. That's interesting. And you can also delete things, right? But it's not a super useful application. Nobody really likes a to-do list. So if we wanted to make something maybe like a notes application, we want to add like name for the name of a note and maybe something like content, right? But content is a type that's missing. So let's go create it. But actually, the IDE that I'm using has like some like LLM stuff going on. And I found that in like sufficiently small and well-structured styles, it kind of does get some stuff right. So it actually is like, hey, do you want a string? And I do, in fact, want a string, so I'll add that. And I do need to add it to the actions, and it also knows how to do that, which is great. I also knew how to do that, but it's faster when it does the reasonable thing, and then I can tell it when it's wrong. So we just updated our type, our actions, our updates, and if we had the console open, we would see it probably is erroring now. Probably every time that I've hit save, you would actually see the error that's created by the like type mismatch that we're introducing by changing the type before changing the agent. But if you wanted to, and if you were unfamiliar with like this application, you could actually go through here and like use that to debug like what do I need to change in my agent to get things working. So you could just start out with what you want your data model to be and work backwards that way. But practically, we're going to go into demo 2, and because we're familiar with sort of like what this is doing, we know most of the changes we need to make are in the onPoke arm. Specifically, we have this like handle poke thing, which I think is like similar to what is done in the tutorial everyone's done, and we're basically editing some state with recursion and publishing out some stuff that people might want to subscribe to, maybe not. But we know that we need to edit these. So we have ID, name, and action. And if we go here, we want to add content both when we're editing it and when we're publishing out. It actually is suggesting to me that maybe I want to update delete, but I don't, because to delete we only need the ID, and that didn't change. So the suggestion it would give me here is wrong. And I need to do the same thing in update, though. So in updates, it was trivial because like the action was the same as the noun we'd construct, but now it's not. So let's go and write that. Yes, it should be the shape of update. And we need to get the ID comes from the action in the case of the update. This looks good, so I will save what it generated. And the interesting one, right, is for this bit of recursion for actually updating this one, we don't want to update the ID, so yeah, we need to write a comma, but then once we write the comma, the LLM knows what to do. Okay, so now this stuff has been updated. Something that's nice is that this way the scry doesn't actually need to be updated as long as the encoding is updated correctly, but we haven't done that yet. So I can go and do that, which is over in lib, right? So this is how we've been encoding, decoding, and then same thing, we need to add like content, we need to go from string to chord, and if you've done sort of any amount of Gall development, you're probably familiar with this, especially if you're using the React stack that I talked about in that presentation earlier. So that's on the encoding side. On the flip side, we want to also add another one here that, yeah, it should actually be content, and it should be tripping a content property. Okay, great. So automatically, the Gall agent kind of will know how to handle the peak now. And I think after this one, things maybe stopped breaking? Or did I forget one of them? Oh, yes. OK, so this error is different. So this is no longer a syntax error. If we had it open, we'd be having syntax errors every time we made a change. This error is actually good. This is a nest fail, which means that when we ran the app before, this type of the state that was run before now is mismatched during runtime with the new type. Since we haven't distributed this application, I'm not going to write a migration for the type. Instead, we can actually just nuke the agent. Yes, I know what I'm doing. Great. OK, so now it's not running. But if we trigger the builder at all, as part of its process, it'll like commit and then also revive. So it should start. Yeah, OK, so it knows what changed. Everything seems to have worked out and didn't complain about the type nesting either, which means now the only thing broken will be our front end, which only knows how to interact with the previous type. I do want to test this a little before we move over to the front end. So what we want to do is we want to get some debug information and see that it has what we expect. So we'll use the debug tool. And we see there's an items list which is empty. And if we try to add something to it, we can, which is item action is the mark. And we want to create. So we will create first property being the name of my cool note that I'm writing and misspelling. Second property is the content of our note. So I am writing a note from Dojo. Nice. And it looks like it took, and surely enough, if we debug, the state now has the note that we created, which means that if we update our front end, it should also get that, and then we can start modifying the front end and doing some React hacking to make like a nicer UI. So yeah, this is what it looks like right now. Let's open the code, which is no longer in desk. Now we're working in UI, which this template is based off of Create React App. So if you've been doing the React and Gall thing, and if you're familiar with Create React App, it should look kind of familiar to you. And then I sort of, in like the main file, created that UI that you saw. It's pretty trivial. But more importantly, we set up basically the connection to Urbit, as well as like a trivial implementation of like how to send a poke, and a trivial implementation of how to send a scry. And then this is a normal sort of React application doing like forms and managing state with these kind of things you're familiar with if you've done React. But like I mentioned, I don't like writing JavaScript, and I am using an LLM-enabled IDE. So let's try and avoid writing much JavaScript if we can, even though we are using React as for this application right now. So what do I want to do? Well, I need it to know about the property that we just introduced. And so really the section that I care about is the form that is creating those items, because that will break if it runs merely this line, because it won't have the content property. So I can basically go to that form, and I can, oh geez, okay, great. And I can ask, can you update this to also send a content, let's put it in quotes to be clear, property. Extra what?
You got an extra quote between content and.
Oh yeah, content. Okay, the content field should be a text area. The thing that I really like about LLMs is that they understand my typos. So I'm actually not going to edit should there. And I bet it will do something reasonable regardless. Okay, so we're checking the code here. We see it now is including this. And it also has updated the form. There's multiple inputs. There's this text area input. And it's done some reasonable tailwind as well. So it looks good. We'll test it out. So I'll apply that. And oh, you know, I do notice a bug that it's introducing, which is I did not have prevent default. And actually, we don't want prevent default. So I'm going to delete that after we accept this, because that'll prevent the page from refreshing correctly. But yeah, we just changed the form, and we should now be able to create those items.
Don't forget to update your hooks.
Which hooks?
You had a set content in there.
Oh, did I? I don't know that we did. We probably should.
Lower down. I think lower down, because when you're updating the state of contents, it's calling set content. I don't think the set content exists. I don't know if you can-
Oh, no, it does. It does. It's doing that up here.
Oh.
Yep. Yeah, it knows. It's smarter than us all. Maybe, I don't know. It's better at JavaScript, that's for sure. And luckily, I don't like writing JavaScript, as we covered. Okay, so we have that, and actually, in the terminal, it was busy rebuilding. So if we go here, we can actually have a separate tab with docket for our purposes. And come on, buddy. Okay, so in here, demo 2.
Could you modify golem watch to just use con to automate the process of printing blob on JavaScript changes? That'd be ideal.
Yeah, I don't know actually, I couldn't find documentation on how to take that glob and actually get it back into your Urbit, is where I got stuck on that. But I did figure out how to do that, yeah. So yeah, so we're here, and if we refresh, we now have the text field we asked for, and we can test it out. So we also have my cool note, which we wrote on the dojo. So we'll do a second note. Dear diary, I leveled up today. I write my notes in the browser. Yay. And, oh no, did something break? Maybe.
Console? Get that console.
Yeah. You know what broke? It was the reloading. So that means, but you tricked me. I didn't delete the prevent default the second time. This is the bug that introduces.
There you go.
Yeah, that's exactly correct.
Did the display logic get updated to actually show the content?
No, not yet. Well, no, by default, it can display the name still because it knows about the name. but that's what we're going to do next. Yeah, docket upload. Yeah, the order of these also reversed. It's much easier when you have a desk that comes alphabetically before a web term or whatever. All right, cool. So we got this now. I am low on battery. That is true. Okay, I think I didn't wait for that last time. What? Okay, great. So yeah, we have those. Okay, so now obviously this is a Notes app. What we probably want to do is you also want to add the rest of the content, which means we want to go here. I have what again? Great, okay. So yeah, so we grab that part of the UI, and again, update this so that the items are clickable. When clicked, they should show a modal with the item's content for editing. You can tell I used to write a lot of user stories or acceptance criteria. Okay, so yeah, let's check this. Actually, this one will probably be easier to check with the diff, so I'm going to apply it first and ask questions when we're looking at this view. Okay. Right. Modal from React Modal. Yeah, it does this about half the time when I was rehearsing this. And I actually don't like dependencies, but you can ask it to do it with no dependencies. Don't use external dependencies for this. Yeah, create a modal component. Okay, so this will be a bit more verbose. And we should, oh, it's still in this other flow. Okay, so let's reject what it just did and then add the next one. Which, yeah, it no longer imports. It's creating its own modal component. It's managing the state for that component. It's managing the outer state. That looks correct. Let's see more of it. And then, yeah, it has like these functions for opening, for closing. And it also created the form submission for editing, but actually that's because I said for editing and not for updating. Update, ID, name. The rest of this looks correct, though. And do not prevent default. Great. Yeah, okay. So we code reviewed the LLM. Looks good. Glad I'm not the JavaScript dev on this team. And now we save. It's going to rebuild in a few seconds, and then we'll rebuild. Okay, and now we have clickable items that have editing, and we can save them. The last thing that I want to do, because I think this took slightly longer than when I tested, is this is not a good UI at all. I want to update this UI. I hate these cards, so I'm going to ask it to change it and make it look more like a Notes app. So I'm actually going to just, without highlighting any specific code, say, can you update the styles of this app to be more like a Notes app? Colors should be off-white, and there should be no cards or drop shadows. Make the content wider as well. What else can we fit in? Including for the modal. Okay, great. And so with this like template, you can get in, you can start editing your gol types. You can quickly like make kind of the state that you want. And then depending on what you're building your front end with, you can do your sort of preferred method of building, which if it's outside of Urbit, okay to be hackier. We love to see it. Okay, so it just rewrote some styles. And the tailwind I find easier to code review and the diffs as well. So let's accept that and see what it does. OK. Yep, it's changed, yeah, some of the spacing stuff. I think it's making things, for the most part, white, but it's, yeah, let's see what it came up with. We'll review the design in the browser. OK. So as always, upload those files. And let's go. OK. A bit more reasonable of a note-taking app, and it should be, you know, mobile responsive, right? It looks like it did when you're on mobile, but it looks more reasonable on desktop, and we can, in fact, click into our notes, and should ask it to make that longer, probably. Oh, and it got rid of the card. Interesting. OK. But yeah, so basically what I'm demoing here, right, is that if you've been doing any kind of like building with LLMs, using them to like write your Tailwind, write your UIs, if you've been using something like Galileo to just produce really high fidelity designs that you can export to like HTML or React, with this tooling, it's really easy to get started with a reasonable Gall agent, create the like state and transitions that you want, and then you can kind of automate a lot of the front end away, whether you're exporting it to React and doing this, or exporting it to HTML, in which case I would, you can kind of like give it the HTML, and I tested out a little bit of getting it to convert the HTML to sail, and it would do it sometimes. The larger your sail file is and the more examples in file it has to work off of, the better job it does. Still much better at React, but that should improve the larger corpus of like Urbit there is, right? So you can see like, by having this like easy setup, someone can get in, edit some state, and use the technologies that they already know to begin developing trivial or like to moderate complex like applications in just like a matter of like moments, right? Like if I were creating a notes app for myself, I probably would ask it to like, as the next step, like take this and put it into a modal, have a create button, and then you have like a basic like notes clone if you like, you know, did something better with the styling. My preferred like LLM for that is like Galileo. And then if you did that, it's a matter of like implementing actually like your networking. You can actually take like the updates that it's sending out, figure out like how you want to do that for like sending to other ships and so on. And because we're doing all the automation part of this outside of Urbit, you could conceivably have a workflow like this that also exists for like Shrub, right? You can create a Shrub template. You could start like editing things in like the Hoon there, and you could also, you know, take out of Galileo HTML, have it write some like HTMX and like cell type stuff if you have like the context that it needs, and get started building right out of the gate. And you could conceivably, especially for the React side of what I'm doing, you conceivably try this out before even having joined the network. Like if you're evaluating what is building on Urbit like, and you're used to like doing things like building with LLMs, you can like, just test that out because of the tooling as well.